At A-level chemistry, biodiesel is often considered one of the trickier parts of organics. So lots of students kind of leave this out and go, I don't know what's going on. I don't want to look at it. But I am about to make this so easy for you, because once you understand ester hydrolysis, then you understand how to produce biodiesel. Okay, biodiesel forms through the process of transesterification, which again sounds scary, but let's start with hydrolysis and then we'll move our way over to transesterification. So I already have a video on ester hydrolysis, but we'll do a quick recap so that we are all on the same page leading into biodiesel. When we have an ester, which is just this, RCOOR. If we were to hydrolyze that ester, so break our ester bond, then we are breaking the bond here. Now, what we get as our products depends on the conditions under which we are hydrolyzing that ester. So if we were doing this under acidic conditions, so using H plus with H2O, then we would give an OH back to the carboxylic acid part, the O8 part, and then we would give an H back to the alcohol part. And so our product would be, or products rather, would be a carboxylic acid and, actually I'm going to go down the board, and an alcohol. Okay, now if we were to hydrolyze this ester under basic conditions, so using sodium hydroxide, aqueous, right? Then instead, actually I'm going to switch colors. Okay, if we were to use, sorry pen, sodium hydroxide aqueous, then instead of giving an OH back to this C double bond O, instead we're going to give it an O Na, okay, to give us a carboxylate salt. And we still just give an H back to the OH. So we end up with our sodium carboxylate salt and our alcohol. Okay, now transesterification, if we think of it in the same way, it's so straightforward, because when we're adding HOH, we add the H, we add the OH. When we're adding NaOH, we add the H and then we add the O-Na. Now, for transesterification, that just means that we're swapping what the ester is, what the aryl part is of the ester. So instead of adding NaOH, biodiesel is essentially a mixture of methyl esters. So instead of adding water, an acid, or sodium hydroxide, instead we are adding methanol. Okay, again, if you think of water as HOH, if you think of sodium hydroxide as NaOH in terms of the HO there, the H there, the NaO there, the H there, then for methanol, it's exactly the same. We can think of this as CH3OH. So hopefully you can see where I'm going. If not, we're about to go there together. Instead of adding OH or ONA to our ester group, to our O8 group rather, we are going to add an OH. So we're going to add the OCH3 to this carbon, and then we're still just going to add an H to this alcohol. So what do we end up with? We end up with a brand new ester, because now we've got OCH3, we've got a methyl ester, and we've still got our alcohol as before. Okay, transesterification. We have formed a new ester by just switching out what the R group was, what the alkyl part is that's attached to the rest of the ester. And so biodiesel is essentially a mixture of these, but starting with a bit of a scarier starting material. So let's look at this now in the context of biodiesel. Now, we form biodiesel from triglycerides. So triglycerides, especially for biologists, we know it's formed from glycerol, aka propana 1,2,3 diol. and then 3 fatty acids. Those fatty acids can be the same as each other or they can be different. What should we make them? Let's keep it simple. I'm just going to say CH2, 4, CH3, and let's make them all the same. Okay, so a long chain fatty acid. Okay, now to turn our triglyceride into biodiesel, which is our mixture of methyl esters, then just as before, we're going to need to add methanol. Okay, now because in this triglyceride we've got 3 ester groups, we are going to need to add 3 moles of methanol, CH3OH. And then just as we did before, we are going to give the OCH, the OCH3, to this C with the double bond O, the O8 part. And we're going to give the H back to the alcohol part. Because again, we have broken the ester bond. So what do we end up with as our final product? We are going to get our alcohol back, our triol. So CH2, CH, CH2. But now we've got those O's, and those O's now have got H's on them. OH, OH, OH. And then for our part that once was the O8 part, that's now got the OCH part. So, I'm going to even draw it backwards. CH3, O, right? That's this part, OCH3 on the C double bond O with the CH2 for CH3. And because we've done that 3 times and all 3 of these fatty acids are the same, we are going to get 3 lots of this biodiesel methyl ester. And that's it, right? It is basically ester hydrolysis, right? But instead of adding OH if it was an acid, ONA if it was a sodium hydroxide, we're just adding OCH from the methanol. Nice and straightforward. Make sure that you practice lots of these questions. It will become second nature, right? Muscle memory once you've done a few. If you've got any follow-up questions, make sure that you leave a comment. Make sure that you have liked this video and you have subscribed so that you see the next videos when they come out. Okay, see you over there.